We call Earth the blue planet because of its oceans, but that nickname overlooks something far more extraordinary. Earth is the only known planet with fire. You might point to the sun, volcanoes, or lightning elsewhere in the solar system, but none of those are fire. The sun is powered by nuclear fusion in plasma. Magma is molten rock, not flame. Lightning is an electrical discharge. True fire, visible flames from rapid oxidation, exists only here. Fire is a chemical reaction called combustion. It requires three things: fuel, sufficient heat, and an oxidizer. On Earth, that oxidizer is almost always atmospheric oxygen, O2. For most of cosmic history, free oxygen was vanishingly rare. The story of fire is therefore inseparable from the story of life. Early in Earth's history, the atmosphere had almost no O2. It was rich instead in methane, carbon dioxide, and other gases. Then, roughly 2.4 billion years ago, photosynthetic cyanobacteria began releasing oxygen as a waste product. This triggered the Great Oxygenation Event, one of the most transformative moments in our planet's history. At first, all that new oxygen reacted with dissolved iron in the oceans, forming vast deposits of iron oxide, rust, that settled as layered banded iron formations we still find today in places like Australia and North America. Only after this massive oxygen sink was filled could O2 finally accumulate in the air. It took another 1.5 billion years before enough oxygen built up and land plants appeared to provide dry, abundant fuel. By around 430 million years ago, strange early land organisms, tall fungal-like towers called prototaxites and smaller tubular growths, colonized the continents. We know they burned because we found charcoal of that exact age, some of the oldest on Earth. Lightning likely ignited these primitive land dwellers, starting the first wildfires. About 70 million years later, during the Carboniferous period, around 300 million years ago, lush swamp forests of giant club mosses, horsetails, and early seed ferns covered the continents. Dead plant matter piled up because decomposers capable of breaking down tough lignin hadn't fully evolved yet. This buried carbon eventually turned into the coal deposits we mine today. Photosynthesis during this era pumped so much oxygen into the atmosphere that levels may have reached 30 to 35% compared to 21% today. With that much oxygen, fires burned hotter and spread faster. Insects and other arthropods grew enormous. Dragonflies with 70-centimeter wingspans, meter-long scorpions, because higher oxygen made giant bodies physiologically possible. As plants evolved, true wood, leaves, and seeds, fire became an even more powerful force. By the Cretaceous, about 90 million years ago, the first pines appeared. Some developed thick bark and high crowns to survive fire. Others evolved serotiny, cones that open only in intense heat, releasing seeds into freshly cleared, nutrient-rich ground. These opposing strategies emerged at roughly the same time, showing how strongly fire was shaping evolution. Then, 66 million years ago, an asteroid struck near the Yucatan. The impact ejected trillions of tons of incandescent debris that rained back across the globe, igniting widespread firestorms. A thin layer of charcoal found worldwide at this boundary records of brief, planet-wide inferno. Yet life recovered, and in the aftermath, a new fire-dependent ecosystem arose: grasslands. Grasses keep most of their biomass safely underground. Their above-ground parts die back seasonally, creating dense, flammable thatch. Regular fire clears this litter, returns nutrients, and prevents trees from taking over. Without fire, most grasslands would become forests within decades. Today, fire remains a partner of life. Many ecosystems, from prairies to pine forests to African savannas, depend on it for regeneration and diversity. Grasses feed humanity's staple crops: wheat, rice, maize. Grazing animals and the predators that follow them, including the lineage that led to us, co-evolved with fiery landscapes. So yes, Earth is a water world, but it is equally a fire world. No other known planet has both abundant liquid water and an oxygen-rich atmosphere created by life. Only here did biology invent a process, photosynthesis, that accidentally made the air combustible, then produced the exact kind of carbon-rich fuel, plants, that could burn in it. Water gave us life. Life gave us oxygen. Oxygen and life together gave us fire. And fire, in turn, helped shape the living world we know today.